Alright, so for chapter 3, what we're going to start out with is a review of mean and standard deviation versus the median and IQR. So we're going to use the mean and standard deviation if we have a normal curve. The value at the center is going to be our average. And remember, 68% of our data is going to fall one standard deviation above and one standard deviation below. While if we go two standard deviations above and two below, that's going to be where 95% of our data should fall. Now, when we're using the median IQR, we're going to use that when we have skewed data, so either skewed right or skewed left. So remember, if our data is right skewed, our median, aka Q2, is going to be at the center. And if we have right skewed data, that means that our average is going to be to the right, which means it's going to be greater than our median. And if we have left skewed, that means that our mean is going to be to the left, or so a few other things we should remember is that the standard deviation is going to be where you sum up all the deviations, square those, divide them by n minus 1, where n minus 1 is going to be the number of observations we have minus 1, and then after that we're going to take the square root of that number. The IQR is going to be Q3 minus Q1. So remember, the standard deviation and the IQR are going to give us the variation of our data. Also, when we're looking for potential outliers, when we have skewed data, that's going to be Q1 minus 1.5 times IQR and Q3 plus 1.5 times IQR. So remember, if a value is below Q1 minus 1.5 IQR, that means it's going to be a low outlier and the other one will be a high outlier. Also, the average is going to be the typical value. Remember, the standard deviation is going to give us an idea of the spread of our data. Whereas on skewed data, we're going to use Q2, which is the median. That's also going to give us the typical value. And what will tell us the typical spread of our data will be the IQR. Alright, let's get started on some examples. So first example is, suppose we took the weight of 500 apples and found that the distribution was normal. So since it's normal, we're going to use the mean, which was 2.46 ounces, and the standard deviation is 0.38. So we find an apple that weighs 4.1 ounces. What we want to do is find the z-score and write a conclusion in full sentences. So first off, the z-score for this is going to be positive because it's bigger than the average. But we want to know, is it abnormally big? So when we're doing the z-score, we're going to be using this formula. When you're typing in your calculator, make sure that you put parentheses around that top part so your calculator knows that you're grouping it together. Otherwise, you're going to get the wrong answer. So when we type this into our calculator, 4.1 minus 2.46 divided by 0.38, what we are going to get is about, let's see, we're going to get 4.31. So remember, something is going to be unusual if it's more than 2 standard deviations away. So this z-score tells us that it's more than 4 standard deviations away. So let's look at the normal curve and see where that is. So the center is going to be the average of 2.46. So that would be all the way out here. So for a conclusion, we're going to say that this apple is unusually large. Alright, now for part B, what we're going to do is we're actually going to do the opposite. So we're going to use the z-score to say something about the weight and then use that to find the exact weight. So this z-score is negative 0.35. Since it's negative, that means that it's going to be smaller than the average apple. And when it asks us to determine by how much, well, it's less than 1 standard deviation away, so it's not going to be that much smaller than the average apple. Now we want to know, what is the weight of this apple? So we know that z equals x minus x bar over the standard deviation. So we know what z is. It's negative 0.35. We don't know x, the weight of the apple, so it's going to stay as an x. And we do know the average, which is 2.46, and then we're going to divide by the standard deviation. Now when we're solving for x, we need to get rid of that denominator first, so we're going to multiply both sides by 0.38. Okay, that's going to cancel that denominator on the right-hand side. So what that's going to give us is negative 0.133, and that's going to be equal to x minus 2.46. Now to solve for x, we need to add that 2.46 to both sides. And what we're going to see is that our x value is going to equal 2.327 ounces. So we were right, it's just a little bit lower than the average apple. For the next example, we're going to have 5 smallpox cases from 1908 for several countries, and what we want to do is we want to calculate the mean and the standard deviation by hand. On the next video, I'll show you how to do this using StatCrunch. So first note that n equals 5, that's the size of our sample. So x bar, when we add all of those observations together and divide them by 5, that's going to give us roughly 133.8. So now that we have the mean, we're ready to calculate the standard deviation. So we have to take all of our observations and find how much they deviate from the average, and then square them. I'm going to go ahead and skip ahead, and I'm going to give you all of those solutions. Go ahead and pause the video and do that yourself and make sure you get the same thing. So after we get all those deviations squared, the next thing we're going to do is add all those numbers up together. So once we add all of those numbers together, we are going to get 1,274.8. Now we need to divide them by the number of observations minus 1. Remember, we have to put that in parentheses because we're grouping it together. And then take the square root of that. Once we do that, we should get that the standard deviation is about 17.85. Again, I'm going to show you guys how to do this on StatCrunch because it goes much faster. Now in the next example, we're going to be using the empirical rule. So we've collected the number of smallpox cases for 84 countries and find that they have an average of 147 with a standard deviation of 18. So before we even get started on answering these questions, I always think it's a great idea to draw a normal curve. So the center, which I kind of drew off center, but it's okay, just pretend that's in the middle, it's going to be 147. Within one standard deviation, it's going to be 68% of our data, which is going to go between 129 and 165. And then if we go one more standard deviation out, it's going to go between 111 and 183. So when it says approximately 86% of countries can expect to have between, well, that's going to be one deviation. So that's going to be between 129 and 165. For the next one, it says approximately what percentage of countries can expect to have between 111 and 183. Well, good thing that we drew this normal distribution out earlier because we can see that that's 2 deviations away, so that's going to be 95%. Alright, so we're still using the same information for part C. So it says suppose one country sees 115 and another sees 157. Which country is more unusual? So if we go back up here, let's mark where 115 and 157 would be on the normal distribution. So 115 would be there and 157 would be here. So what we can see is that 115 is further away from the average than 157. What that means is that we expect 115 to be more unusual. But let's go ahead and find the z-score and use that to prove this case. So remember, z is going to equal 115 minus the average, which is 147, divided by the standard deviation. Don't forget when you're typing that in your calculator, put the top in parentheses. And the z-score for the other will be 157 minus 147 over 18. So when we plug that into the calculator, what we are going to get is that z equals negative 1.77 repeating, And on the other side, we have z equals positive, because it's a little bit more than our average, 0.55 repeating. So, since 115 has a z-score that's absolute value is more standard deviations from the mean, that means it's going to be more unusual than the other one. Okay, now we want to know what percentage of countries can we expect to have 165 cases or fewer. So we're going to draw the normal curve and label it with the empirical rule to help us out. So again, we're going to have 147 kind of in the middle. I don't know why I keep drawing that off center. We're going to go 1 standard deviation out in either direction. And just for fun, let's go ahead and go 2 standard deviations out as well. So I'll have 111, and then we'll also have 185. So here's something to remember, is that this is a symmetric. So that means that on either side, we're going to have a 50-50 split. So if we just look at the cases that are 147 or fewer, so that means the lower half, that's literally going to be 50% of our cases, or 50% of our countries. Now, let's see how many, or what percentage of countries are going to have between 147 and 165. Well, that's actually going to be 34%. The reason that's going to be 34% is, remember, we have 129 to 165, and that has to be 68%. So if you take that 68% and divide it in 2, it's going to give you 34% on either side. Now, when we add these two together, we're going to have that 50% plus that other 34%. So we can expect about 84% of countries to have 165 cases or fewer of smallpox. All right, these last two examples are going to be talking about creating a box plot and finding potential outliers. So we have the following data. And remember, we wanted to cut this data into 4s so we can find Q1, Q2, and Q3. So since we have 15 observations, our center observation is going to be 21. The center of the first one is going to be 15. And then the other one's going to be 41. So remember, this is breaking it up into 25% chunks. So we have the first 25% are going to be 15 or less. The second 25%, or the other 50%, is going to be 21, 41, and the rest. Remember, so we're splitting up into fourths. So Q1 is 15, Q2 is 21, Q3 is 41. The IQR, that's the spread of the middle, so it's going to be 41 minus 15, so we are going to get 26. 1.5 times the IQR, that's 1.5 times 26, is going to give us 39. Now, before we start sketching a box plot, what we want to do is we want to look for possible outliers. So we have to determine our lower fence. That's always going to be Q1 minus that 1.5 IQR. In our case, that's going to be 15 minus 39. That's going to give us a negative 24. So since we don't have any observations that are less than 24, we're not going to have any lower outliers. For the upper fence, it's going to be Q3 plus 1.5 times IQR. That's going to be 41 plus 39. That's going to give us 80. Now, since we don't have any observations above 80, that means that we're not going to have any upper outliers. So in this case, we checked, which is great, but we found no potential outliers. So that's going to mean that we have no stars on our box plot. So let's go ahead and draw this out. So I'm going to make mine go from 0 to 70. And then I'm going to go ahead and make my tick marks in 7s. All right, so now that that's done, I always start with the box. So the middle part, that's going to give you the IQR. So I'm going to start with Q1, Q2, and Q3. So those are going to be at 15, 21, and 41. After that, I'm going to start drawing my whiskers. So remember, our whiskers are going to go to our lowest non-outlier. Since we don't have any outliers, it's just going to go to our lowest observation, which is 2. and then up to our highest non-outlier observation. So since we don't have any outliers, that's just going to go up to 64. And we are done with our box plot. Like I said, in the next video on StatCrunch, I'm going to show you guys how to do that using technology. Now, the last example is the box plot below shows the property crime rate for 100,000 residents in 50 states. The outlier is Delaware. The regions are the Midwest, the Northeast, the South, and the West. So first we want to list the approximate median crime for 4 regions. The median is going to be that line in the center of the box plot. So we're just going to kind of eyeball this. As long as we're close, it's fine. So if I look at all of these centers, first for the Midwest, if I kind of follow that dot down, it's about 3,000. So I'm going to say that that's roughly 3,000. If I look at the Northeast, drop that down, it's a little bit less than 2,500. So let's say it's approximately, let's say it's 2,250. As long as you're close, that's fine. I don't know if you can tell, but I draw my lines a little crooked. For the South, I'm going to say that's about 4,000 or 3,800. And for the West, I'm going to say it's about 3,500. So remember, that center line is what gives you the median. Now, if we want to list the regions from the lowest to the highest interquartile range, when we look at the interquartile range, that's the size of the middle box. So I'm highlighting the IQR, it's that distance. So if we were to do them from lowest to highest, we would start with the one that has the shortest box length. So that would be the Northeast, which would be here. The next one with the shortest box length, I would say, would be the Midwest. Then the South has the next smallest, and the West has the largest one. Now, if we were to give a verbal interpretation of the IQR for Northeast and West, we're going to do the comparatively. So the Northeast has a smaller interquartile range than the West. So what we would say is that the Northeast has a smaller variation in the rate of crime than the West. So we're not saying that it has a lower crime rate, even though it does. We're saying it has less variation in the amount of crime that we see in the Northeast. Whoops. All right, so we're all done. If you're interested in seeing how to do this on StatCrunch, which is the easiest way to do a lot of these, go ahead and check out the next video, Chapter 3, StatCrunch Help.